I'm going to go over the 5.3 quick check ideas. So first off, this is about oxidation and reduction. So just to get some terms out of the way, the element is oxidized, okay, and we want to be able to look at an equation and recognize when something is oxidized and when something is reduced. Okay, so it's oxidized when it, now we have a mnemonic to help us remember this, and the mnemonic is Leo the lion says grr. I mean, it doesn't mean anything, it just helps us recognize. So oxidation is what happens when you lose electrons. So losing electrons is called oxidation, gaining electrons is called reduction. So an element is oxidized when it loses electrons, okay, and its charge becomes more positive. So if something happens, so it goes from either a negative number to 0 or 0 to positive, or like with Fe, could be go from 2 plus to 3 plus, anything where its charge gets more positive, then that is oxidation. Reduction is kind of similar, just the opposite, and that's when it's going to gain electrons. Okay, when it gains electrons, it becomes more negative. And this makes sense because if you are gaining negative electrons, then your charge gets more negative. If you're losing negative electrons, your charge gets more positive. Now, for a redox reaction, for each reaction, write the charges of the elements. And this is not always trivial, so let's try this. So copper, okay, you have to recognize that copper solid, that is not an ion. That's going to be a 0 charge on that. So anything that's an element is going to be 0 charge. Oxygen also be 0 charge. Now it does form a -2 ion. In fact, here it is in its compounds. It's -2. Okay, 2 minus, but it, just as a neutral element, 0. So in its compounds, 2 minus. Now the copper could be +1 or +2, but in this case, since there's 1 copper with the 1 O2 minus, then this must be 2 plus. So who is getting oxidized? Whose number is going up? Okay, copper is going from 0 to +2. So it is getting oxidized, so the element copper is being oxidized. Now oxygen then, that's being reduced. Okay, and it's going from 0 down to -2. So it's going down, so 0 is reduced. The other thing I think about for reduction is that when something is reduced, its charge is reduced. So it goes from 0 to -2, that's reduction. Okay, same idea again. So here we have chlorine. Now chlorine, neutral element, it's going to be 0. And over here, here's bromine, it's a neutral element, it's going to be 0. Now in its compounds, bromine can be 1 minus, and chlorine can be 1 minus. So that in the compound, those guys are their negative ions. And potassium in its compounds is always 1 plus. Everybody in the first column, in their compounds, they always form 1 plus. So who's getting oxidized? Somebody's number is going up, and it looks like it's not potassium. It must be the Br going from -1 to 0. Okay, so that's going up. So from 1 minus to 0, bromine is being oxidized. And we're talking about who's getting reduced. Okay, chlorine is going from 0 down to -1. Okay, and so that is getting reduced. So chlorine, the element chlorine is being reduced. Now, the chlorine is Cl2 and the bromine is Br minus in this case, but those are the elements. Okay, the other part here is about some single replacement reactions. For each reaction, write the balanced molecular equation and then the net equation, then write the half reactions. So let's go through that. Now we have to think about the solid magnesium. Okay, magnesium is Mg. Okay, it's not an ion because it's not in a compound, just magnesium, Mg. Is placed in an aqueous solution of nickel, chloride. So we know nickel's 2 plus Cl minus, so this is going to be NiCl2. And we said this is single replacement, so the magnesium, because it forms a positive ion, it's going to replace the nickel, and we know that magnesium forms a 2 plus ion, just like nickel's 2 plus. So the compound it's going to form is magnesium chloride, and the nickel just becomes neutral nickel. So the magnesium replaces the nickel, becomes magnesium chloride and nickel metal. So this is the molecular equation because we're going to treat everything as molecules. At this point, it's perfect time to balance. We have one magnesium, two chlorines, one nickel, so this is balanced as written, and we have the molecular equation. Now, using our solubility rules, we can say, well, nickel chloride, chlorides are usually soluble except for silver, lead, and mercurous, so nickel chloride would be a soluble compound. Magnesium chloride, the same thing, would also be soluble. So I'm going to jump down here a little ways, and we're going to write this equation again. So we have magnesium, which is a solid, and we're going to have nickel ions, and we're going to get 2 chloride ions, and that's going to turn into magnesium ions and 2 chloride ions and nickel neutral. So we can see what's going to happen here is the chlorides on both sides of this equation are doing no kind of change. So for the net ionic equation, we leave out these ions that aren't doing anything, and we have a name for those. We call those spectator ions. And we just keep in the stuff that actually is doing something. So the magnesium is reacting with the nickel ions and turning into magnesium ions and neutral nickel metal. Now the oxidation half reaction for this, who's getting oxidized? Well, the magnesium is going from neutral to 2+. So that's going to be our oxidation. The reduction is nickel going from 2+ to nickel. So the last part of this, the oxidation half reaction will be magnesium turns into magnesium 2+. And how does it do that? By losing 2 electrons. And then for the reduction could be, what's the left over? Nickel 2+, picks up 2 electrons and becomes nickel neutral, nickel metal. So that's our oxidation half reaction and our reduction half reaction. Now oxidation, we said losing electrons is oxidation. So the electrons on the right side of the arrow, that's a good indication that that's oxidation. And reduction, the electron is on the left side of the arrow, which means the nickel ions are gaining those negative electrons to become neutral nickel. Let's try the same thing down here. We have, whoops, I just made a mess. Okay, that aluminum metal is placed in a solution of hydrochloric acid. So aluminum metal is neutral LAL. Hydrochloric acid, we should be good at that one by now. We know it's HCl. Now, since we know that aluminum can form Al3+, then it's going to replace the H, and we'll get neutral hydrogen. So we are going to get AlCl3, because we know Cl is -1. And we'll have neutral hydrogen, which we know is diatomic element. Now we have to go back and balance, and it looks like maybe the best thing to do would be to do the chlorines. So if we do 3 chlorines on the right, then we'd have to have 3 chlorines on the left side. That would give us 3 hydrogen atoms, and here's 2 hydrogen atoms. So to get that to balance, we'd have to go back and multiply the left side here by 2 and the right side by 3. So let's go back and do that. So instead of this being 3, let's make this a 6 HCl. And if we have 6 HCl, that we could have 3 H2s. If we have 6 HCl, we have 6 chlorines, so we get 2 AlCl3s, and then the 2 aluminums would leave 2 there. So that's our balanced molecular equation. Ionic equation. Chlorides, we said, are soluble, and so AlCl3 would actually break up, and we would have 2 Al3+ ions, and we'd have 6 Cl minuses. Over here on the left side, we're going to have 6 H pluses and 6 Cl minuses, and we know that because that's a 6, because the HCl is a strong acid, and we know strong acids completely dissociate, and so the 6 Cl minuses are going to cancel out of both sides of this equation. So the net equation, I'll do it again in black, is going to be 2 aluminums plus 6 H pluses turn into 2 aluminum ions and 3 H2 gas neutrals. So here's our balanced net ionic equation where we leave out our spectators, and the spectator in this case were the 6 chloride ions. Okay, oxidation, whose number is going up? Aluminum is going from neutral to +3. So the oxidation half reaction is aluminum changes into Al3+, and it can do that because it loses 3 electrons. Now this is actually happening twice, but for the oxidation half reaction, I think we would just show the single atom changing. And for the reduction half reaction, we have H pluses. We're going to pick up electrons and become H2. And then we can see what happens. In order to get H2, we have to have 2 hydrogen ions pick up 2 electrons and have that happen. So those are our oxidation half reaction and our reduction half reaction. Now when we want to put those together, we have to have our electrons cancel. So this 3 electrons here and the 2 electrons here are going to have to balance. So we're going to multiply this top equation all by 2, multiply the bottom equation all by 3, and that would give us 6 electrons and 6 electrons which cancel, and then we would end up with our net ionic equation. You can see what happens. We would have 6 H pluses turning into 3 H2s when we multiply everything by 3. When you multiply the other part by 2, we get 2 aluminums and 2 Al3 pluses. So that's our molecular, net ionic, and oxidation and reduction half reactions. That's it.